So today we're actually going to do something useful, not just preparation. I mean, the other stuff was useful too, but preparation is actually most of the job often. But we're actually now going to actually see results, which is cool. So I decided, as we discussed, that I'm going to try to hook these libusb libraries. Technically I'm not hooking the library because I'm just recompiling the library, but what I'm doing is basically what people would call hooking, which is I'm going to insert some code before the call runs, and the call that was built in runs, then do some stuff. I'm just doing it a lot easier than the traditional hooking, so I'm just going to call it hooking. Anyway, so where we left off, we were looking at the serial number and the security check. So today I decided I want to actually try seeing if we can replace the serial number. And first, though, we want to actually hook the code again, and when it actually reads the security number, I want to print it out to the screen, or I want to log it to that log file so that we can actually see if my assumptions are correct. So looking at this from the key manager method init, there's one of the first thing it does is get the key family code, which is actually not part of the key manager class. This is the USB IO code. I mean, it's technically on the key, but it's part of a different section of code. So get family key code calls this read key ID, which ultimately calls this read USB memory. And the way, if you look at it, the way things look is anytime it's accessing reading USB memory, that is the IO board. It should be called maybe read IO board memory, I don't know. But what it does is it does two USB operations. One, libusb control transfer with these hard-coded arguments, and then something that's not hard-coded, and then another one. What this is doing here is this is actually telling the USB code that it actually wants to send a request to the USB device, and that's what this line does. And then this retrieves the results. So what I want to do is I want to actually, whatever USB control transfer is called, I want to actually compare the data that's sent to it, the parameters or the arguments, and based on what I see, determine whether it's the serial number call. And you can see whenever it reads a serial number, these arguments are fixed. The one argument, to read USB memory, the second argument is this value here, and then 8, which is the length. Okay, so this Windex was that hex number, and the length is 8. And then these first two arguments are hard-coded. So basically, I figured out what so Windex, which is that offset, and then length. When you do the length, it actually shifting it 8 bits and then ORing it with 3. And so that is, so if we do 8, well, let's do Python minus I to do the quick computation. 8 shifted 8 ORed 3 is 2051. So that one argument, I think that's the fourth argument to libusb control transfer, is going to be a 251, so we're looking for that. And then the other argument for the first call, where it's sending the data, was just that weird offset, okay, which was hex 1C31. And then these two arguments are, this is 12, so the second argument to libusb control transfer is 12, and then 161, then we're going to have a 2051, and then that offset. So that is when it actually is sending the request to do the work, and then when it comes back, it's going to be looking for the numbers 192 and 160. Then it's going to also be looking, one of the fields is going to be the length of 8, and we actually don't care what this field is, that's the data. So we're going to look for only those fields, the 162, and what was the other number? I don't remember. And then a length of 8. I don't remember, but we'll look at it. I already put in the code. Okay, so let's bring up the code that I've altered, and the code to handle the USB lib I'm sorry, libusb control transfer is in the libusb directory, and the file is called sync.c. So what I did here is, this is the normal code, libusb control transfer. And what I did here is I wanted it to not hack up this code itself very much. So I'm putting very minimal stuff in here. One thing I did add here is this extern file debug, because again I want to be able to write to the file. And then immediately, once we get into the call, I'm going to actually call my own code, do hook, and send all the arguments that were actually sent to libusb control transfer. And then I'm going to analyze them and decide if I want to actually do anything or not. And if most of the time I'm not going to want to do anything, because most of the time we're not reading the serial number from the key. So the reason I'm doing this again is just it's going to be a little cleaner. I could have actually, and when I was messing with this last night, I put all the code directly in this function, but I decided I want to move it away. So these are the two things I'm adding, and then I'm going to add a little more later down. Okay. I also added my own function and my own what's called an enum, my own data type. So I have this hook action, which is just a we'll call it opaque data type. Basically, these are just integers, but I don't have to actually put the numbers. I'm gonna refer things as do action, or I'm sorry, no action, or do serial. Okay, and that's how I'm going to communicate with the code. So here's my code. Hook action. It's going to take all the same arguments as the first one, and basically what it's going to look for is it's going to look for whether it's getting that initial transfer. Okay, this is the request for the serial number. This is actually, I'm sorry, this is the response for the serial number. This is the request for serial number. Oh, no, I'm sorry. Request for serial number. This is the serial number data request. Okay, so I had it labeled wrong there. But what happens is I'm going to look at it, and if the arguments are what I want them to be, what I'm looking for, then I'm going to set some flags, and I'm gonna actually set some debugging or some output messages. Here's my output message in the case of a request, or the response request, or the actual initial request to do the action. And then I'm going to log it. And I also want to see again if my whole if my whole theory is correct and I'm doing this right, is when it requests it, I'm actually going to when it actually is requesting the response, I'm actually going to send some data back to the libusb control transfer, basically this do serial, which means it's going to actually print it to the file. And then once I know that everything is correct, we will actually cause it to always just print the data. I'm going to actually hard code a serial number in there and actually just have it always send that. And that's step one in the process. We'll then hacking process. Then we'll have to actually override the code that actually checks if the key is physically inserted. And but I think this is a little more interesting right here, just seeing if we can suck the serial number off from the device without actually looking at the serial number that's actually physically on the key. So anyway, so if it's any of those two requests that the read key ID calls into the libusb control transfer with those parameters, I'm going to basically log the information, and then I'm going to send a message back to libusb control transfer. And when it actually is done with the transfer, if the action I returned is do serial, I'm just going to print the serial number. Okay, so I already compiled it, and I copied to the Megatouch. Let's see what we see. So here we go. We have the results, and we see the libusb was successfully called because we made that change in the last episode, or libusb, and it was called. We got the control transfer, that is the request for the serial number, and then the control transfer that actually sucks the response from the USB device, and there it prints a serial number. Now, I've X'd these out because I don't want everyone to see my serial number. So this is the family code, I think. or the checksum. I don't remember. This is one of these is the family code, one is the checksum. I don't have a problem giving those away. But the interesting thing is, when I actually compared that to my real serial number, they weren't the same. They looked nothing like that. Oh, I don't want to say it looked nothing like that. It was not correct. So I was like, "Oh, that's weird. I'm pretty sure this is right." So I went and looked at the code, and then what it actually does is, after it reads the data back, it XORs every byte in the code by 8. I have no idea why. Maybe this was in a way, again, of trying to do copy protection. But when I unXORed everything, or I XORed it again, because when you XOR something again, it actually removes the results of, so XORing again actually sends it back to the real number, and it actually turned out that yes, that was my serial number. So now that we've been able to read the serial number from the USB control transfer call, all we have to do is instead modify our code to replace it with a fake serial number. When rather than printing it out, we're going to replace it basically. So I just changed the code a little bit. I modified things a little bit. Basically, I cleaned the code up. So what I did here is basically I put my serial number in here, and again I exit out in this case so you don't see it, because I don't want to give everyone in the world my serial number. And then I encode the serial number the way it wants to be encoded with that XORing 8. And then basically, when it requests the response, I just write that modified serial number to the address that it gives me, rather than let USB I/O control transfer do it. And basically, that's it. So now let's see what happens when we replace the library and boot it up. And you can see that it works. Now we also want to just make sure it's really working by putting the wrong number in and make sure it actually fails. So let's see what happens. I modify the serial number, make it incorrect, and then copy the library over and reboot. So you can see that it did not work, which is what we expect. And it's important that you always check that, because I might have went ahead and changed the library out and maybe forgot to actually replace the library correctly or something, and it might have been working, and I might have been all this time thinking that it's working when it's not. So it's always good to test to make sure that things work and also fail when they should fail. So great. So the serial number hacking part is replaced. Now we have to replace in the next video the serial key detected part, and then the actual read of the key data. And we'll see, that might be it, or there might be more we need to do.